Now we're going to look at the lymphatic system. Actually, the lymphatic system is closely related to the blood as well as the next lecture, which is the immune system. So before we label all these things, we are going to take a note on the lymphatic system. So let's start with something that we're familiar with. Here is our capillary, and we have the arterial side and the venous side here. By now you should know that the blood is made up of plasma, which I will show in yellow here. I mean, it's not separated within the body, but I'm just drawing it to help you visualize it, I guess. And we're gonna have some blood cells here. Okay, so these are my red blood cells. They're basically happy face without the eyes. Based on our discussion on capillary exchange, you might remember that the blood pressure on the left side here, on the arterial side here, is going to be greater than the osmotic pressure, and because of that, you're going to experience fluid loss. Okay, so here we have BP, blood pressure greater than osmotic pressure, resulting in fluid loss. So the stuff that comes out is basically a component of the plasma. So here I'm going to put plasma. And then what happens once the fluid comes out? Well, once it comes out, this fluid is actually going to be going into the space that is between the cells in the tissue. So here I'm going to draw some cells. Okay, so these are cells in the tissue, and there are some space between these cells. So once the fluid leaks out from the capillary because of the pressure difference, they are going to fill up this space between the cells. Okay, so the fluid that are existing between the cells, we call them interstitial fluid. Interstitial fluid. Okay, and some of these fluid will then travel to the other side of your capillaries, and they're going to go back inside. And that occurs because on the venous side, the blood pressure is less than the osmotic pressure. So you're going to be able to draw the fluid back in. But if you remember our previous discussion, the pressure difference here is about 10 mmHg, right? Difference in pressure about 10 mmHg, right? 30 for BP and 20 for OP. But over here, the pressure difference is approximately just 5 mmHg, which means you're going to be losing more fluid than you're going to be able to bring back in on the other side. So what happens to all these extra interstitial fluid? Well, that's where the lymphatic system is going to come in. Okay, so parallel to your blood capillaries, you are going to have these lymphatic vessels. Okay, lymphatic vessels. So here is one of them, and let me label that for you. This is the lymphatic vessel. So the excess fluid, the interstitial fluid that were not returned, to the blood circulation, they are going to go into these lymphatic vessels. And once they are inside the lymphatic vessels, we call them something else. Okay, so these are the fluid inside the lymphatic vessels. We call them lymph. Okay, lymph. So essentially, the lymph are derived from the interstitial fluid, and the interstitial fluid are derived from the plasma. They are mostly water, and they are very similar in terms of the contents, in terms of the kind of ions you will find in them. And so the lymphatic vessel will carry these fluids towards a converging point. And let me just show you that in this picture. So you might have another lymphatic vessel from another part of the body, and then that's gonna have some lymph in it. Okay, I'm just gonna use this green color instead. And then you might have another lymphatic vessels from another part of the body carrying lymph in them. And what happens is all these things are going to come together in a big structure. Okay, and this cluster of circular structure is actually your lymph node. Okay, so you can feel your lymph nodes around your neck area. You have some under your armpits, some in the legs, in the groin area, and the doctor can feel your lymph nodes and see if they are swollen, and they would be swollen when there is some kind of infection or something. So all these lymphatic vessels will be carrying the lymph, and then the lymph will be passing through the lymph nodes. Within the lymph nodes, you are going to have various types of white blood cells. And then the white blood cells are going to basically check the contents of the lymph, and if there's nothing foreign in it, if there's no bacteria or anything in it, what happens is, let me just extend the blood vessel here. What happens is then the lymph is going to continue forward, and eventually they are going to merge with your vena cava, and that's how the lymph is going to turn into your circulation. Okay, so another thing that's worth mentioning here is that because the lymphatic vessels are not connected to a pump, like it's not connected to the heart like the blood vessels are, so to keep the fluid moving forward, there are going to be some valves here. Okay, so these valves are going to ensure that the lymph will not become stuck in one place. They will continue to move forward, right? So both lymphatic vessels and veins, they both have valves in it. Okay, so before we go any further, let's just quickly summarize this in another diagram. Right? Basically, the fluid started in the plasma. Plasma is the fluid components of blood. And because of the pressure difference between blood pressure and osmotic pressure, some of this plasma is going to come out and become the interstitial fluid. Okay, interstitial fluid. Some of these interstitial fluid will then return to the plasma on the venous side, and you can see it right here. Right, the blue thing comes out, and then some of it's going to go back on the venous side, but some doesn't, because the pressure difference is not the same on the arterial side and the venous side, so you won't be able to take everything back. So whatever you don't take back, they are going to go into the lymphatic vessels, where they will become lymph, and the lymph will travel through these lymphatic vessels. They will pass through one or more lymph nodes, and eventually they will also return to the plasma. So there's no net loss of fluid. So you might be wondering, why go through the trouble of leaking out and then only to return it later on into the system? Well, actually, this is an important mechanism for detecting foreign antigens in the system. So let's say you have a like a thumbtack again or something, and this time the thumbtack carries some bacteria. Okay, some bacteria here. So as the lymph is washing in between the cells, it might pick up some bacterial products, okay, maybe some bacterial antigen, and then these bacterial stuff is now going to be carried into the lymphatic vessels. So when these lymph passes through the lymph nodes, then the white cells are going to be alerted. They're going to be stimulated. And that's how you mount an immune response, right? So the cells in the lymph node might start to undergo mitosis, to divide and to multiply, so that they can fight off this infection, and that's part of the reason why your lymph node is going to get swollen when you have an infection. So we're going to talk more about this in the next lecture, but this is basically like a really simplified version of the relationship between the lymphatic system and the cardiovascular system. Let's go to the workbook, and if you scroll to the end of the workbook, you're going to see the end of lecture 2. You will see there is a diagram here, and we're going to label this diagram together. Okay, so this diagram shows the various lymphatic structures that we found in the body, and we are going to start here at the top. Okay, so in the head area we have tonsils. Okay, so tonsils. We actually have 3 pairs of tonsils, Some are in the back of the throat. Some are at the back of the nose, and we will take a closer look at where they are when we get to the PowerPoint slides again. So here there are tonsils here, and they do have different names, and we'll get to it when we get there. There is the thymus here. Okay, so this here, that is your thymus. I'm gonna put thymus right here. So thymus is where your T cells mature. You might remember T cells are examples of agranulocytes, and they kind of coordinate the immune response. So they are made in the bone marrows like every other blood cell, but then they migrate to the thymus where they will continue to mature. That's why they're called T cells. Over here we have the spleen. And you might remember we talked about the spleen. That's where you will recycle old red cells, but it turns out spleen actually plays a little bit of immune function as well, and we'll look at that when we go back to the PowerPoint. So the spleen is a small organ on the top left quadrant of your abdomen. Okay, it's actually right behind your stomach. Over here we have just lymphatic vessel, lymphatic vessel, and you can see the lymphatic vessel will actually merge here with your superior vena cava in this case, and that will return the lymphatic the lymph within the lymphatic vessels into your general circulation. Over here we have the bone marrow. So bone marrow is where all the white cells come from. So of course, this is going to be part of the immune, part of the lymphatic system. Right? The bone marrow, it's in the middle of the long bone. Over here, we have another lymphatic vessel. They are really all over the body, right? They are next to your blood vessel, and basically every time you have a capillary, right next to it would be the lymphatic vessel. Sorry, I have a spelling mistake here. Vessel. I think I spelled it wrong here as well. Just got distracted a little bit. There you go. So lymphatic vessel. Remember, the lymphatic vessels, they all kind of come together and they converge at these lymph nodes. So if you pull a lymph node now out, you can see there are multiple vessels that are feeding into the lymph node, and after the lymphs are filtered and surveyed, then there is going to be an exit point there. If we zoom into one of these sections within the lymph node, we can see what's inside. So this is basically a same diagram as what we do here, okay? But this one is just way more compact, but hopefully it will make sense. Right? So here you can see that there are two types of vessels. Okay? So I'm gonna highlight the blood vessel. So this thing here that I'm outlining, that would be your blood vessel, your capillaries, for example. Okay, so there it is, and you can see all those little circles inside the blood vessels. Of course, they are going to be your red blood cell. Okay, so this arrow, it's basically pointing at the plasma, right? We'll say the plasma. Okay, let me color the plasma as well, so that we can see it better. So there, I'm going to use yellow for the plasma. Okay, so the fluid components of the blood with the ions and nutrients and whatnot. Then that stuff is going to come out, and they are going to become the fluids between your tissue cells. So these cells are outside of the blood vessels. They are part of the tissue, and the blue I'm coloring right now, that's going to be your interstitial fluid. Okay, so here I'm going to just do another section. Okay, so I'm trying not to color the cells. They shouldn't really be colored. There we go. So that blue arrow, that line right here is pointing at the blue stuff, and that is the interstitial fluid. interstitial fluid. Remember, these stuff are derived. That means they came from the plasma, so they're very similar in terms of content. So some of it will return to the blood, but some of it is going to enter the lymphatic vessels. And once they are in the lymphatic vessels, they are going to become lymph, okay, which is what this green stuff is, the lymph. Okay, so there is an arrow right here pointing at the lymph. Right, so lymph. Okay. Now the lymph inside the lymphatic vessels, they have to circulate back into your general circulation. But then, since there's no pump, that's why we need to have valves. So there is a valve within your lymphatic vessel. And there's another label here that's pointing at one of the cells. So this would be a cell in the tissue. Okay. So there. You have it. It's basically what we've talked about, but in a much more compact diagram. So back to the PowerPoint now. Here is something called lymphedema. This is what happens when the lymphatic vessels, the valve, is not working, or if the lymphatic vessel has become blocked, and so there's no way for the fluid to return to general circulation, and all that excess fluid is just going to build up in your tissue, causing very, very severe swelling or edema in the tissue. And as you can imagine, this is extremely, extremely painful, and you know, a lot of times where this happens is in developing countries, and people don't actually necessarily have access to the care that they need to fix this problem. So that's called lymphedema. In fact, local people call it elephantitis, because the size of the swelling resembles that of a limb from an elephant. So lymph nodes, we talked about that already. They are ovoid structures that are found in clusters, and there are some major clusters, as we talked about, in the neck, in the axillary, the armpit area, in the groin area. And typically when they are swollen, it indicates that there is some kind of infection nearby. If you get strep throat, for example, right, your lymph nodes are actually going to be very swollen, and it's going to hurt when you touch them. Again, right, that's because of the white cells activity that's going on within the lymph nodes. Basically, the lymph nodes will filter the lymph, and they will increase in cellular activity if they detect some kind of pathogen. So this is basically like the theme of all of the lymphatic organs that we're going to talk about. Same thing here with the tonsil. And the tonsils, as I said, there are 3 pairs of them. So this is your nose, and at the very, very back end of the nose, that's where your adenoid tonsils are. Over here, this is your mouth. This here, let me just outline that. This is your tongue. It's actually quite big. And at the base, back of it, that's where your lingual tonsil is. Lingual means tongue, right? So that's one of them. And there is another one kind of at the back of your throat here. That is the palatine tonsils. So if you go to a mirror and you open your mouth and say ah, you should be able to see your palatine tonsils. Okay, so that's one of them. That's the other one of them. And if you have a tongue depressor or popsicle stick, that's basically what they are. If you press down on the tongue, you should be able to see your lingual tonsil right here. Okay, you cannot see your adenoid tonsil. Okay, your adenoid tonsil is all the way at the back of the nose. Okay, no, you won't be able to see that, without proper instrument. So the tonsil basically would survey the air that you breathe, right? And the lingual one and the palatine one would basically survey the things that you put in your mouth. The spleen, as I said, it's behind your stomach. This would be your diaphragm, and so it's just going to be right there below the diaphragm, behind the stomach on the left side. We already know that it's going to recycle old red cells, and it's also going to do the similar lymphatic function as the tonsils and the lymph nodes. And there is an extra thing that it does. It can act as a reservoir for blood. It doesn't hold a lot, maybe 20 milliliters of blood, but you know, if you're bleeding out in an accident, for example, then the spleen can supply a little bit of blood just to keep the blood pressure going. Hopefully, you know, long enough before help arrives. A person can live without a spleen. There are certain conditions that requires the removal of the spleen. It's called splenectomy. And once you remove your spleen, then of course, as expected, you will be more susceptible to infections. Next, we have the thymus. Don't confuse the thymus with the thyroid. Okay, so thyroid is higher up here in the neck. That's the one that gets big when you don't have enough iodine. The thymus is actually kind of just in front of the heart at the top here. And the size of the thymus is actually going to be shrinking as we age. And that might be one of the reasons why our immunity is not as good when we are older. Immature T cells will move from the bone marrow to the thymus, where they will continue to mature there. And you know, before they can come out, they have to do what's called a tolerance test. Okay, so a tolerance test checks to see if the T cells are going to be attacking anything within the body. Okay? And it turns out only 5% of the T cells are going to pass the tolerance test. That means up to 95% of the T cells that you create are going to be destroyed, because if you let them out of your system, let them out of your thymus, for example, they are going to end up attacking your own cells. Okay, so we want them to not attack your own self. Okay, if they attack yourself, you might end up having autoimmune diseases. Okay, and that is not a good thing. Example of autoimmune disease would be something like ALS, right? That's what Stephen Hawking had. Another one is multiple sclerosis. You might have heard of that, where you have progressive neuronal degradation. And another one is lupus, for example. So all these are autoimmune diseases where you have your white cells attacking your own cells. So in the thymus, there is a hormone called thymosin, which will help with the maturation process. So that's all for lecture 2. There's a lot of stuff here, so please make sure you take the time to review the material, do the workbook as always, and you know, check the answers afterwards. Thank you for watching.